Ten Toes family. It's your boy Tony, and you're watching TentoezTV. Yo, we have some crazy reactions today, right? And it's about quantum computing. If you guys don't know what quantum computing is, so the simplest version that I can say is it basically takes the most difficult problem that a supercomputer takes years and years and years to solve, and it solves it within minutes. Now, that's the kind of technology breakthrough that we are nowadays, and everybody's in a race with quantum computing now. I know China has a resource that is good for quantum computing, or not that's good for it, but is like a prime foundation of quantum computing, right? And I don't know if they're the only ones that hold it. So now imagine if they stop giving that to anybody, or the US, or who they're selling it to, because of what's going on. And this is kind of irrelevant, but with the USA China trade war now, so quantum computing can be kind of scary because it's not like AI. Imagine if they can get quantum computing at a level that they can solve real world problems. Are they going to, basically rely on a robot to solve our issues? And what can that do for everybody, or let's get into it. But yo, without further ado, or you know what, let's say one more thing. Thank you, Ten Toes family. We almost got 100 subscribers. And it won't be very long, before like we be doing our giveaways. We're trying to do our giveaways at 3,000 subscribers. And we got some cool things to give away. But yo, like and subscribe. But let's get right into it.
This is a chip manufacturing tool. This is the biggest molecular beam epitaxy tool in the world, as far as we know. And this tool is making a very special material that we
Look
need
at
to
that thing.
realize any kind of useful quantum computer.
California-based startup PsiQuantum is one of the many companies working to make large-scale quantum computing a reality.
We are inside the Stanford Linear Accelerator cryo plant that makes liquid helium, and PsiQuantum is using a little bit of that helium, and what we do is we load chips into this cabinet to cool those chips to very low temperature. So this is minus 270 degrees Celsius. It's about 2.3 Kelvin base temperature, which is the same temperature as deep space.
That's crazy.
Quantum computers promise to solve problems that are impossible for traditional computers, with the potential to transform entire sectors, including material science, pharmaceutical research, and financial services. Investors have also been bullish about the technology's future, with some quantum computing stocks rallying over 1,000% in 2024.
If investors are looking for the next big jackpot, it sounds like they're really focusing attention on quantum computing stocks.
Excitement around quantum computing reached a fever pitch after Google announced its Willow quantum chip at the end of last year.
By our best estimates, a calculation that takes Willow under 5 minutes would take the fastest supercomputer 10 to the 25 years. Or a time scale way longer than the age of the universe.
Since then, a slew of other announcements from other tech giants have sustained that hype around and investment in the technology.
Microsoft announcing what it calls a quantum computer breakthrough with its new Mayowana 1 chip.
Amazon jumping into the quantum computing race with its first chip.
We're going to open a quantum research lab in Boston.
Everybody.
It will likely be the most advanced accelerated computing hybrid quantum computing research lab in the world.
Intel and IBM are also working to develop quantum technology, as are governments and numerous startups. The United Nations has even proclaimed 2025 as the International Year of Quantum Science.
It's a new class of computation that
That's
I think
scary.
can dramatically change most aspects of industry, commerce, and science.
By some estimates, greater than $50 billion have been pledged to quantum technologies, of which quantum computing is one, by governments around
A lot of
the
money.
world.
Despite massive advancements in the field in recent years, right now these quantum computers are not able to solve the big real-world problems. It's still more theoretical. CNBC visited one Silicon Valley startup to find out
So let me
how
pause it right
close-
there, right? So it's theoretical what she's saying, and also this is all speculation and theory what I'm about to say. So, right, what if they, finally get that one piece that's missing to quantum computing, right? And like they said, they don't want to, rediscover, they actually want to start designing things. What does that mean for our pharmaceuticals, our food? What does that mean for, what they're doing in medicine, hospitals. Does that make sense? Like, they're going to try to modify things, and that's all speculation and theory, but imagine what they're going to try to modify if they can design new things, right? Let's get to it.
We are to having a useful quantum computer and spoke to experts about the major challenges this tech still faces as engineers work to transition it from lab experimentation to commercial viability.
This is all on CNBC News, guys. Like, this is all there. You gotta check it out. I'll leave the original video link in the description.
Has been around since the 1980s when physicists first suggested that quantum mechanics could be used for computation. By taking advantage of...
All right, let me pause it right there. Yo, they said they've been starting quantum computing since the 1980s, right? And what we see is all we see. Imagine all that they have. You got to think about it like that. It's all speculation and theory, but they probably got some real supercomputers now. You know what I mean? Let's get to it.
Quantum physics, quantum computers are able to produce huge leaps in processing power and solve problems that conventional computers simply cannot manage.
There are two really important special quantum mechanical properties that give quantum computers an advantage on classical computers in solving certain types of problems. The first is called superposition. The second is entanglement.
Unlike classical computers, which store information in bits, with each bit representing either a 1 or a 0, quantum computers use quantum bits or qubits, which can exist in superposition of 1 and 0.
So let me pause it right there. Yo, so basically what that means, right, is say the standard supercomputer, it gathers information, and as it's trying to solve the problem, so one equation, it takes time solving that one problem. And the possible outcomes little by little, one by one, as quantum computing in qubits. Basically what it is it's simultaneously gathering all possible outcomes simultaneously, continuously. So that's how they're able to get their answers fairly quickly, and that's like a fast version of it. Let's get to it.
Multiple possibilities simultaneously. Qubits can also be entangled, where the state of one instantaneously affects the other, no matter the distance. These properties enable quantum computers to solve certain types of problems exponentially faster than classical systems.
Unlike classical computers, quantum computers can directly simulate that behavior. And that allows us to design things instead of just discover things. All our drugs...
See what I'm saying?
Gone into the Amazon, we've pulled bark off trees, we've seen how many mice die, and we've tried to make an oncology drug just by guessing and trying to optimize around stuff we discover. But being able to design materials directly, to be able to design chemistry, drugs, catalysts, requires a tool where we can simulate nature, and quantum computers are the first ones that can actually do that.
Quantum computers could also help with agriculture.
The way fertilizer is produced today comes at a really steep cost for companies. They're spending about $100 to $300 billion a year, and for the environment. 3 to 5% of the world's natural gas is annually used for fertilizer synthesis. Scientists today know how to use computers in order to find a much more energy efficient alternative. The problem is it would take even the fastest supercomputer 800,000 years to simulate all the maze-like molecular interactions of the key catalyst. With a quantum computer, it could be less than 24 hours.
But quantum computers will not replace conventional computers for everything. Some sectors could benefit more from the technology than others.
It won't replace AI. They are complementary technologies. Anything that is large data and small computation is not advantage.
Let me pause it right there. I don't think it will replace AI either. I think they're going to try to merge AI with quantum computing, and that's the scary part. That's the scary part. That's some iRobot stuff. This is just hypothetical things. Let's get to it.
Quantum machine. Optimization problems, physics problems, how we design fusion reactors.
Let me pause right there. That reminds me, physics problems, right? So China's leading in tech, right? Now, imagine if they use quantum computing to make that artificial sun. And that's exactly what they're doing. They're using quantum computing, and that's exactly why the US wants to do AI and quantum computing. because China's almost figured it out. Let's get to it.
How we design superconductors, how we explore this incredible design space. Think of the most extraordinary applications.
Analysts estimate that the 4 industries likely to see the earliest economic impact from quantum computing are mobility, chemicals, financial services, and life sciences, which stand to gain up to $2 trillion
That's
in
expensive.
value by
$2 trillion?
PsiQuantum says it's already working with a number of enterprise partners to experiment with potential use cases.
We're working with a bunch of different companies. So Boehringer Ingelheim, for instance, a large European pharmaceutical company, Mercedes-Benz, Mitsubishi Chemical, and various other Fortune 500 companies as customers and partners. They're working with us today with the hope that a quantum computer will allow them to design drugs, materials,
That's what's scary.
fuels, catalysts, and really give them a new level of mastery over chemistry and physics that they hope will give them a profound competitive advantage in these areas.
Ironically, the same quantum properties that make quantum computers really good at processing complex problems also make the technology extremely difficult to work with.
Unlike classical bits, which are physically stable and robust, qubits exist in highly delicate quantum states, and these states are easily perturbed by even the smallest interactions with the external environment, things like thermal noise, electromagnetic interference, vibrations, acoustic noise. The other challenge is that quantum superposition is ephemeral. So superposition allows qubits to represent multiple states at once, but maintaining this state requires precise isolation from the environment.
Think of coherence as a way of keeping a quantum system stable so that it can run calculations.
The whole difficulty of constructing a quantum computer is making something that, on the one hand, cannot interact with anything, right? On the other hand, you can control it. But controlling it means it's interacting with something, right? So it's like this very, very difficult engineering problem.
Quantum companies have been experimenting with different quantum technologies, each with its own drawbacks and benefits.
There are superconducting qubits, there are neutral atom qubits, there are trapped ion qubits, and then there are other qubits which you see a little bit less industrially.
Google, IBM, Amazon, and Rigetti Computing are all betting on superconducting qubits, while Xanadu and PsiQuantum use photonic qubits. In February, Microsoft announced that it had created a quantum computing chip, Majorana 1, that uses a new type of qubit known as a topological qubit. The technology required the creation of a new state of matter that could
Pause it right there. A new state of matter? What does that even mean? A new state of matter. Let's get to it.
Quantum computers more resilient to noise and shorten the technology's
How small that
development
is.
timeline from decades to years. The sensitivity of qubits to external environmental factors also makes quantum systems very prone to error. For many qubit technologies, managing this error has meant having to keep quantum chips at extremely low temperatures.
The icon of quantum computing is the chandelier. That system is all about cooling these chips to very, very low temperatures. And so they have to run deep space temperature, liquid helium temperature, very, very cold.
Errors are also mitigated through the use of special algorithms that allow experts to correct errors faster than the machine can make them. This is something Google demonstrated with its Willow chip.
The Willow chip effectively operates below what's called the surface code threshold. Historically, when technology providers have added more qubits to the system, the overall system has a higher total error rate. What Google demonstrated is that with their error correcting code, adding more qubits to the system actually reduces the overall system error rate, and therefore there's a path to scaling with more and more qubits.
Peter Barrett, whose venture capital firm is a major investor in PsiQuantum, says that while Google and the other tech giants have made huge strides in quantum technology, he believes quantum computers based on photonic qubits, like the ones used by PsiQuantum, are more practical to scale.
Willow is the best quantum computer on the planet at the moment, but the machine PsiQuantum is making is 10,000 times the size of Willow. And the nice thing about photons is that they're much, much easier to keep isolated. And
That's
it's much
crazy.
easier to maintain the quantum state. And taking advantage of the fact that we have trillions of dollars invested in silicon photonics, in fiber optic
Yo, let me
cables.
pause it right there, right? Yo, Ten Toes family. I just wanted to say thank you guys very much. This wouldn't all be possible without y'all, and thank you guys for watching this far. And if you aren't subscribed, yo, like and subscribe. We got a lot of entertainment going on, and it's a good time. Yo, shout out big baby boy daddy baby Draco. Ah, look at him over there. He just crashed out. Yeah. Yeah, he's the baby boy. And yo, we got some couples content coming out soon. Me and my wife are gonna be doing reactions on ghost videos and stuff. So make sure to watch them with someone at night because they're gonna be spooky. But yo, let's get back to the video. Let's get to it.
Photons become a really strong candidate for building large machines, and their physics is well understood.
Part of that strategy, PsiQuantum is also moving away from the classic chandelier design of quantum computers in favor of a server rack design that you typically find in a data center.
Generally, the approach that we have here at PsiQuantum is that as much
It's
as
like
possible,
a giant
to
warehouse
build the
computer.
quantum computer like a conventional computer, as opposed to a science experiment. And so we use regular semiconductor fabs, pretty normal chips. We use packaging that would be familiar to somebody from the semiconductor industry.
In February, PsiQuantum unveiled Omega, a quantum photonic chip that the company says contains all the components necessary to build utility-scale quantum computing.
That's crazy.
Chips are
What?
manufactured by New York-based Global Foundries. Another major barrier to scaling quantum computers is the lack of a highly technical workforce needed to design, program, and run quantum systems.
Currently, the talent pool is just far too small to meet the demands of the growing industry.
One way to overcome this talent problem may be by using more computers and leaning on artificial intelligence.
Already, we're using large language models. IBM, I think, was the first company to pioneer this in order to actually supplement developer knowledge bases and allow
Yo,
LLMs
let me pause it right there. This is just speculation and theory, right? What if they're using AI to gather all the information that AI is gathering to feed it into quantum computing to get this process done even faster? That's crazy work, y'all. Yo, drop a comment. What do you think about that? Let's get to it.
program quantum computers, which I think will drastically alleviate the workforce upskilling challenge in quantum computing.
But it goes both ways. AI development could also benefit from quantum computers.
There are great AI tools that can help with designing some aspects of quantum computers. And once you have a quantum computer, you can produce training data to train AIs.
The potential of quantum computers to solve some of the world's hardest problems, like coming up with new drugs or materials for more efficient electric batteries, has many people excited. But it's challenges like this that have led some of the world's most influential technology pioneers to temper expectations about just how close we are to a useful quantum computer.
If you kind of said 15 years for very useful quantum computers, that'd probably be on the early side. If you said 30 is probably on the late side, but if you picked 20, I think a whole bunch of us would believe it.
Following Wang's remarks, the market was quick to react.
Shares of quantum computing stocks having a volatile start to the year after a steep run-up in late 2024. Many are now down double digits in 2025 and concerns about just how soon the technology might be commercially viable.
We agree with Jensen, of course, that quantum computing is not here yet. And really the basis for his comments is that today there are small quantum processors. Google's system, for instance, that's about a 100 qubit system. The general consensus is that you need about 1 million qubits to really deliver on these world-changing applications.
At NVIDIA's annual software developer conference in March, Wang gave quantum experts a chance to prove his timeline wrong.
This is the first event in history where a company CEO invites all of the guests to explain why he was wrong.
We think of ourselves as like 10 years, where you were 10 years ago. It's going to be another 10 to 15 years to get to where NVIDIA and all the other giants are.
That's sad.
The complexity of quantum computing has generated controversy around some of the achievements in the field. For example, some experts and competitors are questioning Microsoft's topological qubits breakthrough that the company said would help it build a working quantum computer in a matter of years. Microsoft's research published in Nature in February, though the company said in an emailed statement that it submitted the paper almost a year prior, and during that time, Microsoft has made, quote, tremendous progress.
The exotic physics that Microsoft is pursuing is incredibly exciting, but it's a step along a journey that will ultimately yield something useful, but it's unclear when.
Microsoft said discourse and skepticism are part of the scientific process and that additional data will be shared in the coming weeks. Although quantum computing may not be ready for prime time today, tangible progress is being made.
I do think there are going to be results this year that hint towards real quantum utility for commercial applications. Technology that started off as a quantum computing modality is now being used to make ordinary MRI machines 100,000 times more sensitive and allow them to directly image cancer metabolism. Technologies to see 2 kilometers underground to find the critical minerals for the energy transformation, that's already happened. And then the prize of the really big machines, the million qubit machines, we know is only a handful of years away.
Public interest in quantum technology is growing. The number of quantum computing proof of concept enterprise projects surged by 50% between 2022 and 2024 to over 150 active projects. Consulting firm Booz Allen, Airbus Ventures, and Bosch Ventures have all invested in quantum computers. Meanwhile, Shadbolt says Illinois is investing $500 million to construct a quantum computing campus in Chicago, of which
That's a
PsiQuantum
lot.
will be the anchor tenant. PsiQuantum has also received $620 million from the Australian and Queensland governments to build a utility-scale quantum computer in Brisbane, which the company says will be operational by the end of 2027. Experts say investing
That's
now
fast.
is a
That's
smart move.
close.
When quantum computers reach quantum advantage, which is effectively the period in which quantum computers outperform classical computers at important real-world problems, it'll be much, much harder to get your hands on a quantum computer unless you're developing partnerships with the major providers right now.
Plus, Langioni adds quantum computers don't need to be perfect to be useful.
We had practical implications for classical computers before classical computers were error corrected. Whether computers were doing atomic simulations for the Manhattan Project, they were doing important work for the Census Bureau. We think that there's a potential for
Okay,
the
let me
same
pause it
thing.
right there, yo. That just kind of that shows my theory. I was like, they might use it to weaponize. Yo, atomic simulations. Come on. You know, at least use those resources to find out how we can live longer. Not, you know what I mean? Come on, guys. Let's get to it.
In quantum computing. And candidly, we're even looking to the next 12 to 18 months for the announcement of the first example of industrial quantum advantage that would come before error correction. And then 2029 is when we think the real inflection could come in terms of massive value creation for end users in the right industry.
Shadbolt is also optimistic.
You know, when I arrived in Silicon Valley 8 years ago, a lot of people, really serious technical people, told me that self-driving cars would never happen in my lifetime. Too complicated, too difficult. And of course, now every other car that we see in San Francisco is a Waymo. And so quantum computing has a similar sort of trajectory. What we're seeing now is a big leap to go from the small systems that we have today to the very, very large systems that are required for any kind of useful application.
Yeah, Tento's family. That was the video. Now, check this out. He just said, or they just said that, right? It's supposed to all happen by 2029. Imagine 2029, 2030. Yo, the new Call of Duty game's supposed to be in the year 2030, right? Yo, we're gonna have to try to find some things out about that game because yo, the Black Ops 2, that had a lot to do with what's going on right now. And what's crazy is that game was made years ago, years and years ago. But yo, leave your comments about how you guys feel. Yo, don't mind the messy hair. Sorry guys, I'm doing dreads, so I'm dreading my hair and it's a little bit of a process, so it might look a little awkward in the beginning, but yeah, so that's a video on quantum computing and there's a lot going on in the world and honestly, this technology is improving really, really quick. I would look into it. I don't know how much resources quantum computing takes, but obviously it looks like a lot. Plus AI takes a lot of resources, guys. We're running this earth dry. We're running this earth dry. So yeah, Elon Musk, you got to get us to Mars, buddy, because this earth is going to become inhabitable. Speculation and theory. Like and subscribe. Thank you for making it this far into the video. And also drink your water and eat your breakfast. Yo, shout out big baby daddy boy Draco. Yeah, he likes being in the videos, and that's his spot over there. So it works out. But yo, on to the next one and later.